These are your Integrated Math 2 Section 3.1.2 notes. This is video 2 of 2. This is Module 3, Topic 1, the functions derived from linear relationships. Our learning target is I can solve absolute value inequalities. Pause the video, get this down in your notes, and I'll go to the examples. All right, example number 1, we have the absolute value of negative 8x is less than 40. So we're going to break this into two inequalities and remove the absolute value bar. So we'll have negative 8x is less than 40. On this side here, we would be multiplying both sides by negative 1 to get the negative 40, because it could be negative 40. We know when you multiply or divide by a negative, you flip the sign from your IM1 days. So we're going to get negative 8x is greater than negative 40. All right, now we're going to solve both inequalities. So we're going to divide both sides by negative 8. Divide by negative 8. Oh, I'm dividing by a negative 8. What do I have to do the sign? That's right. We're going to flip the sign. So we get x is less than, negative over negative is a positive. So we're going to get x is less than 5. Then on this one, do the same thing. We're going to divide by negative 8. Divide by negative 8. Oh, we're dividing by negative both sides. We got to flip the sign. So we're going to get x is greater than 40 divided by negative 8 is negative 5. So now let's look at the number line. Look at the number line for this situation. And let's just put in our dividing points. We have a 5 here. We have negative 5 here. We know 0 would be somewhere in the middle. That's good enough for our number line. So what would x is greater than negative 5 look like? X is greater than negative 5 would be an open dot at negative 5 and an array going like this forever. Okay? X is less than 5 would be an open dot here and an array going like this forever. So is this scenario going to be an and or an or? That's right. It's going to be an and. It's going to be the intersection of these two rays. So our solution will look like this. I'll do the solution in red here. We'd have an open dot at negative 5, an open dot at 5, meaning that 5 and negative 5 are not part of the solution, but every value in between those is part of the solution. Okay? So this is a and. And then we gave you a little bit of a trick in class. This is the y, but the trick in class was, oh, this is a less than. Less than is an and situation. Okay? When we have a greater, it's going to be an or. We'll see that in a moment. So this is our solution. How do we write it? We're going to write it as either x is greater than negative 5 and x is less than 5. Or from your IM1 days, you use the compact form if you like. Put x in the middle and we know it's less than 5 and it's greater than negative 5. Read it from here. X is greater than negative 5 and x is less than 5. Okay, so either way I take in my class. Okay? All right, next example when you're ready. Example number 2, we have absolute value of x plus 7 is greater than or equal to 21. So again, it's isolated. Let's break it into two inequalities, but this time we do have a greater than scenario, and it's also or equal to. All right, so let's take a note of that. So we're going to have x plus 7 could be greater than or equal to 21. And then we're going to have x plus 7 is what with negative 21? That's right, we got to flip the sign, so it's less than or equal to negative 21. All right, so now let's subtract 7 from both sides. Do we have to flip the sign when we subtract by 7? No, we don't. We don't flip the sign, right? It's only when you multiply or divide by a negative. So we're going to get x is less than or equal to negative 28. This side, same thing, subtract 7, and we get x is greater than or equal to 14. All right, let's make our number line. It doesn't have to be real pretty. You just put your dividing point. So I'm going to put negative 28 here. I'm going to put positive 14 over here. I'm going to guesstimate 0 would be like right around there. Good. Good to go. All right, so what does x is less than or equal to negative 28 look like? Well, wouldn't that be a solid dot on the negative 28? Actually, I'll do it right here. solid dot on the negative 28, an array going less than would be this way, right? Negative 29, negative 30, negative 31, those are smaller numbers. Okay? X is greater than or equal to 14, it includes the 14, so solid dot, and then the array goes like this. Okay? From your IM1 days, is that an and or an or graph? That's right, it's an or, right? So our solution is X is less than or equal to negative 28, or X is greater than or equal to 14. So you only need to hit one of the requirements, right? It can be, if you get a number that's greater than 14 or equal to it, it's good. Get a number that's negative 28 or smaller, it's good. That's different from the previous example, right? The and means it has to be both. Greater than negative 5, and it had to be also less than 5. It means two requirements for and, or it's just to meet one of the requirements. Okay? Take down your notes and go to the next example. All right, last example, example 3. This one, you notice that the absolute value bars are not isolated by themselves. We got 2 in front of this, we have -4 here. So first thing we want to do is we want to move the 4 here using the addition property of equality. So we're going to say +4 plus 4. So then we have 2 times the absolute value of 4x minus 9 is less than or equal to 54. Now I need to undo this. So we undo this with division, multiplication, right? Undo multiplication with division. Divide by 2. Divide by 2. Now, if this was -2, we would divide by -2 both sides, and we'd have to flip the sign. But we're divided by a +2, so we're okay. Don't change the sign. So then we get the absolute value of 4x minus 9 is less than or equal to half of 54, which is what, 27. All right, now we're in business. We've isolated the absolute value bars, and we need to write 2 inequalities. All right, so I know I can have 4x minus 9 is less than or equal to 27. And I know I'm going to have 4x minus 9. Wait a minute, I need to have negative 27, so we're multiplying by negative 1. So I flip the sign, greater than or equal to. Okay, so now we're going to solve both inequalities. Add 9, add 9. We get 4x is greater than or equal to, what's that, negative 18, I think. Yep. And then I'm going to add 9, and I get 4x is less than or equal to 36. Then I'm going to divide both sides of the inequality, divide by +4. So do not change the sign, right? And so I'm going to get x is greater than or equal to, what's that, 4.5 or 4.5? Call it 4.5. All right, and then this one, divide by 4, I get x is less than or equal to 9. Okay, I need a little more space. I'm going to scroll down a little bit. All right, so let's put this on a number line. All right, I have a dividing point 9. I'll have 5 here, 4 here, 0 will be over here. Okay, if I want to put a few more points, I'll put a 10 there or something like that. All right, got my number line. And so greater than or equal to 4.5, wouldn't that be a solid dot at 4.5? And it'd be an array going like this. Less than or equal to 9 would be a solid point at 9, an array going like this. Less than or equal to. So what we're looking at is, what is the overlap between the two? The two arrays. That's going to be our solution. It has to be both requirements. So our answer on our number line, we have a solid dot at 9, solid dot at 4.5, and it's the segment between the two. So again, this is an and situation. So how you write it algebraically, it's going to be x is greater than or equal to 4.5 and x is less than or equal to 9. And of course you can do the compact style as well. Again, the little trick or the cheat is absolute value bars are isolated on the left hand side. If it's a less than or equal to less than, you know it's going to be an and situation. If it was a greater than or equal to, it would be an or. But again, this is the why. Okay? So that's it for this topic. Thanks for taking your notes.